Broadcasting from the commodity capital of the world, Zurich, Switzerland, this is Insider's Guide to Energy.
This edition to Insider's Guide to Energy is brought to you by fecularities. Go to www.fecularities.com for more information.
Welcome to Insider's Guide to Energy. I'm your host, Chris Sass, and with me as always is co-host Johan Oberg. Johan, what's happening?
Good evening, Chris. Another great week. Was so happily surprised this morning, or actually the couple of days we've been discussing COVID since we started this podcast. And finally, there's light in the tunnel, especially now coming out of Switzerland and the Nordic countries. So hopefully we can get together with our guests in the near future.
Yeah, I'm expecting to do that. I was on a call earlier today, already making plans to travel. So, I like the restrictions coming up. I think also you said it's been a good week. I think it's interesting. One of the threads I've been following on Twitter this week is there's some conversation about whether nuclear energy and gas are renewable, because apparently in the EU, those are considered renewable now.
I guess we've had a few guys on the show before. We talked about regulations and hitting the sustainable goals, etc. And if you can tweak a few things of them, I guess that's one way of doing it. But I saw that a few countries were opposing this quite heavily, and some of them were driving it. So it comes in a little bit now to the political factor, I guess.
Yeah, I think so. And I think it'll be interesting, but there is a lot of heated discussion, a lot of passion. So my Twitter was very much alive over the last 24 hours of people. And I think even on LinkedIn, I was seeing conversations on that, which was kind of interesting. But rather than going into that, and rather than talking about skiing, because I'd be happy to do that because it's been snowing this week as well. So I'm looking forward to this weekend and getting back up to the mountains. So our audience, I think, got to see that picture of you and I a couple of weeks ago out skiing. But I think we have one more weekend planned for us to go skiing. So we could talk about that. But what I really want to talk about today is heat batteries and what that means. So this current guest I found, I think he came through my feed on LinkedIn. I started reading something he put up and I said, that sounds interesting. We should talk about this on the podcast. And so I really had no idea of what heat batteries were. He kind of made me feel silly on the pre-call. And he said, well, do you remember in the 80s when they had these things called heat batteries? And I looked like a deer in the headlight and said, not really. and so we got a brief education there, but I'm super excited to have this topic on board. I don't know. What do you think about heat batteries?
No, I agree. And I totally agree. And as you can see also, if you are looking at the YouTube video, I even wear my vest today because it's freezing cold at my house. So that's maybe something we can discuss. But I think it's an interesting part as well, because we talked about the ecosystem around the energy, but we haven't touched so much on consumer products or for houses as well, which is something that I think will be quite interesting, and also to understanding it. We've had batteries on before, but what is the difference? What does it do? What is revolutionary?
But I think it's initiatives, right? So I remember in the US when we moved to these wonderful things called LEDs, and you had to go buy all new light bulbs and things like that. But if you looked at the energy consumption in North America when the regulation went into place, the household usage of energy dropped significantly, and it wasn't because we all stopped using all our appliances and things like that. It's just we had a more efficient way to light our houses, and it became regulated, and that's all the light bulbs you could buy, right? So if we take another argument and you say, okay, well, heating is something that we do at our house, or cooling or whatever, but heating in this particular example, there's a lot of energy that probably goes into that. So if you could systemically change the way people heat in cold climates, I bet that would have an impact to the demand of energy. But I'm no expert, but I think our guest might be. So
we certainly hope so.
Let's hear it from the expert. I'd like to introduce this show is James Macnaghten. James from Caldera. James, welcome to the program.
Chris, Johan, thank you very much indeed for having me on the show. I'm always slightly nervous when I'm called an expert, so I will do my best. But with the heat battery, it's I think the problem we haven't found is really sort of storing thermal energy. So it's sort of best word we've come up with to describe what we do, but we don't produce electricity and there's no chemicals. What we do is we take electricity in, we convert it to heat, we store it until you need it, and then we let the heat out in a nice controlled manner. And the simplest example that pretty much everyone's familiar with is a hot water tank. It does a very similar job. You heat your hot water tank up different times of the day. It just sits there until you want your shower or your bath. That is a thermal store. I would say with heat batteries, what we're doing is I like to think quite a bit more sophisticated, but it's really a new take on really what's a very old technology.
All right, so you dove right into what it is you did, which is awesome. And I want to find out more about that. But maybe I'd like to find out more about who you are and what company you're with first, because I'm all for the heat battery, the concept, and I understand how a hot water heater basically, I heat it up, and when I want hot water, I turn the knob, and there's hot water there. I think that there's probably some economic advantage to the reason we're going to talk about your company is to maybe when renewable energies perhaps are available, maybe that's a good time to heat up, or maybe I heat up when the energy costs are low. But before we get there, tell us a little bit about your background. So how did you get to be at this company, and how did you get into the heat batteries?
So I trained as an engineer, and I had a slightly varied career. I would say I took at least a good 10-year detour from engineering before returning to it. And I ended up spending 10 years running a UK company called Isentropic, which was looking to store, this is sort of late 2000s, early 2010. We were looking to store electricity as heat, where you would take electricity in, convert it to heat, and store it in very large thermal stores. And then when you wanted the electricity back, you would reverse the processes. And this was being done at a time when wind was much more expensive, solar panels were much more expensive, but you could see what was coming. You could see that there was this sort of huge cost reduction process going on in the renewables world, and to me it was pretty evident that you wanted ability to store energy and be able to shift it from one period to another. Um, so that was sort of where my background came. Caldera itself is a 2.5-year-old company. I founded it with Guy Winstanley, who I've worked with for the better part of a decade. We're a relatively small company, so we're based in the UK. We've got 12 employees, and I would say, we're probably at the start of our journey in that we're putting units into people's homes to heat them, but we're certainly not where we want to be, which is, firing these things out of a factory at 10 an hour or whatever number we can manage to get to. So we're sort of, so I think, so we're, but I sort of, because of my earlier background, I've sort of watched this space for a very long period of time, and you're exactly right, which is, we are developing a technology it's only relevant when you have lots of renewables on the grid, and we're only just starting. People might think we've got lots of renewables on the grid. I promise you, there's like so much more coming.
So if we go back a little bit, then I'm just curious, and I'm not an engineer, so that probably begs the question. But you mentioned there's no chemicals. I can understand the concept of a boiler, a hot water. Obviously, that's something I've had in my house. But if there's no chemicals, how does it work? And how long can you actually store? How long does it last?
So for us, we sort of, I say we go fairly hot. So we make a 1.3 ton block of this material that we've designed and patented, and I sort of describe it. It's solid, and I sort of go, well, it's non-flammable, non-toxic, non-corrosive. It's safe. It's made from a lot of recycled materials. It does have stones in it, and you can recycle it at the end of the life. So we basically have a big 1.3 ton block. We then heat it up to 500 degrees Celsius. So consider that to your oven, which goes to 250, and it's the same heat again. And we basically keep it between 200 and 500. And when it's at 200, we say effectively it's empty. It's still got energy in, but we just treat it as empty. And when it's at 500, we say it's full. And we put the whole thing in a giant thermos flask. So it's within a vacuum chamber space, which is why it then keeps the heat in. And just to say, so from 500 to 200, if I just left a unit, it takes 21 days to go from 500 to 200, which we're really pleased about. It's because it's small and it's hot, and that's hard.
So it sounds like the Yeti mug for heating.
It is the Yeti mug for heating. So and I think my view, I think my whole our thinking was that, you know, you want something low cost to put the heat into. You now want to keep it there, so that's where the insulation. And then the last bit is we have a really nice way that we take the heat out and put it into your home. So from a homeowner's perspective, it behaves just like a boiler. You set the temperature at 75 degrees C. You have a pipe coming in, a pipe coming out. Your central heating switch is on, and we heat the water up to that temperature. So from the homeowner's perspective, we say it behaves like a boiler. The same power output, same temperature. You don't need to change anything inside your home.
So obviously a boiler, you have X amount of liters of water. And in terms of this one, what is the capacity? How long does it last? Is it
Okay,
hours, days?
So it's got 100 kilowatt hours of energy that you can use in there. And if I was to compare it to a car company that makes a home energy battery system, but I won't mention their name, it's like the same capacity as 7 of their large batteries. If you were to look at it in terms of hot water cylinders, and like a 150 liter hot water cylinder, it'll heat up about 14 of them.
So I think the premise you said earlier, what I heard was there's the tip of the iceberg basically for renewables. You know, people think there's renewable everywhere. It's yet to really have the impact it's going to. Why is this a renewable solution? Why does this make sense with renewables and not with more conventional? Or why didn't this work in the 80s when they tried to do it when there was nuclear power and other things? What's changed in the environment?
So interestingly enough, it works really well with nuclear, and most of the storage in the world today has been built because of nuclear. So we built dams where you could pump water up a hill. Pretty much for every 3 gigawatts of nuclear power station, we built 1 gigawatt of pump hydro. And there's some lovely graphs where you show they were literally built together, and that was to use the nuclear energy at night. We also had these things called night storage heaters, which was what you referred to at the start of your call. They were quite popular in Germany and the UK, and they're a bunch of bricks with some insulation that you heat up even hotter than 500 degrees. They normally go to about 600, and you would do that overnight on a special 7-hour rate of electricity, sort of cheap rate of electricity. So a lot was being done. So nuclear is good. My biggest reason I don't tend to mention nuclear is because it's just not being deployed in any large numbers, and it's just being closed down. We work really well with nuclear, and we work really well with wind and solar. And the reason is that once you've built these types of generation, the cost of producing electricity is basically zero. So you want to produce whenever you can. If you're nuclear, you want to run constantly all the time. If you're wind and solar, if it's sunny, you want to be generating. And neither of what I've described to you, which is the nuclear power plant running all the time, or a solar or wind farm, actually matches the generation requirement, the demand of the customers. So customers tend to want the most demand comes in the morning and the evening. There's a higher point during the day, and maybe between 12 and 5, it's quite low. Wind systems in Northern Europe can last 2, 3, 4 days. And so you're going to have these periods when there is more generation, definitely at the low periods, but potentially there's more generation than you need for 2 or 3 days. And we're sort of moving from a world where I describe it where historically we've turned power stations up and down to meet the demand of the customers. Actually, we need to turn the customers up and down to use more or less energy depending on what's working on the grid at the time. And it's a very, very fundamental shift in how we manage our electricity networks.
So, but I think that is what I was trying to say in my opening statement, where I give the example of LEDs, where the demand was reduced by technology change. And what I'm hearing you say is, well, actually, you still need to heat this. There's still energy used. So you're not necessarily changing the demand so much as the flexibility of when you demand it, which means that you can level the power out on the grid or when you use it. Is that true?
It is true, but we're doing two things. We're taking homes that are heated, let's say, by oil or natural gas, and we're converting them to electricity on a one-to-one. So, and at the moment, the alternative, there are two options sort of to heat your home if you want to electrify it. One of them is direct electric or time shifting, which is what we're offering. The other one is heat pumps. Now, we're really clear. Heat pumps, when they can be installed easily, great. They're the better solution. If you can reduce your energy demand by 3 times, that's absolutely fabulous. If it's more than that, great. The problem is to get a heat pump performing well is tricky in older housing stock. It can be done, but there are sort of financial implications of changing radiators, pulling up floors, adding extra insulation, and our argument is, so you go and put heat pumps into the homes where it's easy. And our argument is there are certain types of homes where you're better off not trying to change that economically. Just you're going to need something to soak up this off-peak electricity. This is where heat batteries come in. So we sort of see a world of heating, and to put the heating in context, I think in the UK they had a peak demand. We had something called the Beast from the East, which was like 4 days of cold weather, and the electricity demand peaked at 50 gigawatts and the gas demand peaked at 300 gigawatts. So we can soak up a small number of homes can soak up a huge amount of energy. And part of the value of that from the grid is we're tackling these homes that are very hard to decarbonize with a heat pump. But on top of that, we're providing demand for the wind farms and these sort of zero marginal cost generators that actually makes the economics better, so you can keep installing them. Because if you don't have flexible demand, you hit a point where you're suddenly throwing away half of your electricity you're generating and you stop building.
So how green are these things to make? So you said you'd love to get to the point where we're spitting 10 of these out an hour.
Yep.
What's the impact making these things?
So when I do a sort of life cycle analysis, if I use, most of our materials are recycled. We use steel, which is not. But if you look at the energy process by a unit over the life, if I use new materials throughout, it's something like it's about 2% of the energy processed goes into making it. If I use recycled materials, which is what we're broadly doing, it's less than 1% over the life. So it's really, really low. And then the nicest thing is, once I've got to the end of life, I can simply make another unit with it.
Great. And then how big? I see pictures behind you. Our audience doesn't see it. They look like a little bit of a robust hot water heater, a little bit rounder. But you mentioned that they have all these materials in it, and it looks like a heavy thing. So if I'm replacing my boiler down in the basement, how do I get these things into my house?
You don't. Well, not our one. You don't. It weighs 1.8 tons. So we tend to be targeting homes with oil. So they tend to have an oil tank outside. They have an oil boiler. They tend to be in rural areas, so they've got more space. We're not going to put one into a small terraced house in London. There's no space for them. So they're 1 meter in diameter, 1.8 meters high, but you need a bit of space around them. And one of our challenges always is, where do we put it in your home? So the places people like to put it aren't often the easiest ones to get to from a installation point of view.
Understood. All right. So there's a very specific niche this fits. How big is the market?
If you just to look at homes, so we don't have a breakdown in terms of within of subsets of houses. There are two ways you can look at this. In the near term, we're focused on homes with oil, but broadly it's larger homes with space around it. So in the UK, there's about 1 million. In Europe, there's 14 million, 14. So you could be looking at a replacement rate of 700,000 units a year. If you look at the overall market for heating, it's about 8 million units a year in Europe for boilers get replaced every year. And our view is that we are suited to broadly the larger detached properties. So within the UK market at the moment, I would say there's about 25% that would probably fit within our initial criteria. How much that then splits down to actual factors around installation that mean we wouldn't work, we don't, we're working on that, but we don't have a number.
So in terms of replacing an oil driven boiler, is there any, I don't know anything about this industry, but is there a regular churn? How often do you replace one of these? And how do you see a cycle on this in terms of actually doing? Because there's a cost implication of actually doing something. The biggest problem is doing that it's easier not doing anything.
So the average age of a gas boiler in the UK is meant to be about 11, 12 years. And it sort of gets to the end of the life and there's a problem and your installer says, well, you might as well just buy a new one. They're not very, gas boilers are quite cheap. Oil boilers tend to be more expensive. And from my experience, it's at least 20 years on average of the life. I have seen a boiler recently that was over 50 years old.
So not massive churn.
No, there's not massive churn. I think there's about 40,000 a year in the UK get sold every year. So it's from our side, that's still a very big number.
For sure.
And you get so that's the oil boiler market. They're also oil boilers tend to be bigger and heavier, and a lot of people just don't like. So a lot of people I talk to just don't like having them because you do get leaks from oil tanks, and it smells. I don't know if you've been around oil boilers, but they do tend to smell a bit when they're running.
Well, in the U.S., I remember oil also for your property. There was some hazmat issue of having oil stored in the old tanks. And whenever you get a home inspection, you had to see if they had oil at one time, and there was some risk there as well. So I don't know if that's the same in the UK, but that was clearly for the U.S. home market. If you looked at older homes, you probably weren't as excited if they didn't do a graceful job of getting rid of their oil tanks.
Yes, and look, they do tend to have little leaks and drips. So I think most people would prefer not to have an oil tank. That's my experience. But again, as you said, the inertia is why change anything? And there may be some regulatory points where from 2026 the UK government's consulting on not allowing you to buy a replacement one. But then again, you can keep an oil. When is an oil boiler a new boiler? And you can replace a lot of parts. So I think from our side, it needs to be driven by cost effectiveness and really low cost, cheap electricity. I think most people will change if they will pay slightly more to change. And when I say slightly more, 5-10% more. I don't believe people will pay 50%, 100% more, or the ones that will are a much smaller subset. So it's a very much around time of use pricing versus the price of oil.
Yeah. So if I look at it from your perspective, what's the life cycle of one of yours? If we put it into my house tomorrow, how long will I have it?
20 years. That's the design life.
That's the design life, 20 years.
That's what I think we can make it for. Yeah.
And looking at it, because I read that the UK, as every other country now, has put out a CO2 free or CO2 neutral by 20x. I think it's 2050 in the UK, and then everyone plays around with these numbers, like Chris said in the beginning, if it's now also with gas or with nuclear. But are there any kind of grants or incentives from governments? You touched on this a little bit in terms of replacing. We see with electric cars, I'm from the Nordics, where they were quite quick out in terms of doing the replacement or actually the incentives of moving to electric cars. But with such a hard and home offices and homes are the biggest, kind of one of the biggest ones. And wouldn't that be a great way to kind of subsidize or support this change so we get rid of the oil quicker?
So to answer, there is no grant. We're too early stage. You can get a grant for a heat pump in the UK.
So heat pumps, okay.
So it's the boiler upgrade scheme. I have a very mixed view of grants, in that sometimes it's very hard to wean yourself off them. And so in the example, there's enough money for 20,000 installs a year for the next 3 years. What you then tend to is feast or famine. Everybody's running around trying to install their unit. Then the money runs out, and everyone goes, "I'm stopping now," and I wait. And then suddenly you've got no work for 4 months because people's head, they're like, "I want that £5,000, which is what it knows." I would much rather get to the position where it's a straight commercial sale and proposition, and you get there if you have the right pricing structure in electricity. So you can do one of two things. You can either put the right pricing structure in place and go, when the wholesale price is low, the consumer can buy it for a low price. When it's high, they buy it for a high price. Or you end up going, no, we're going to put a whole lot of charges on at the moment, which is part of what they do. They put network charges on, they put social charges for previous wind farms wind turbines have been built. And so you end up going, and then you go, I need to pay people to be flexible. And I'm like, if you actually have the right market structure, you don't need to pay people to be flexible. They simply will do the right behavior because it makes economic sense.
So what I've heard you say in our pre-call when we spoke about this is that although you're producing and installing units right now, eventually you see this model maybe licensed out or going somewhere wider as well. Is that still, did I misunderstand, or is that correct?
No. So I think there were two aspects to it. When we put a unit into someone's home, we end up, just because of the way the unit, in charging it, when it's discharged, you get to understand really accurately how much energy that home uses, and heat usage. Heat usage is the sort of, I always sort of try and describe it that you use 1 unit of energy for electricity normally. If you put an electric vehicle in, you'll now use 2 units on your home. Your hot water is the 3rd unit, but actually heating is 3 more units again. So the heating and hot water is like 2/3 of your home energy usage. So but the heating bit is very much related to temperature. So in our world, we see a scenario where you sign a deal with your energy supplier, and they say to you, look, every unit of electricity you use, I'm going to charge you, I don't know, 20p, 25p. But every unit I put into your heat battery, I'm only going to charge you 5p. You let me decide when to charge it. You can take heat out whenever you want. And the energy supplier, they can now aggregate hundreds of thousands of these units. They can look at the fact that it's going to be windy for the next few days. They decide when to charge it. And it allows them to manage their customers' demand to match everything they, to fit in with the, the generation of the market. And to me, that's the sort of where we're trying to build to slowly, which is most homeowners have no interest in heating. I think I read somewhere that if they spend 30 seconds a year thinking about their heating, that's about, I clearly have, need to get out more because, I think about it, but most people I know just, some of them don't even know whether they're on gas or oil.
Yeah, but I think right now with the price of energy, people are keenly aware that they're spending more than perhaps they had in the past. But what you described to me sounds like a plan where if I were sitting over in your shoes, I'm in the cheap seats here, as I say, I'd be working with the developers of the renewable projects and have this be incorporated into their business plan where they're selling your unit, almost subsidizing, bringing the unit in a model like you just said, right? So, if you use this kind of technology, it gives me a more predictable customer for my variable renewable. So when it's really windy, I can afford to sell it to you cheaper, and I'm not going to run into that energy into the ground or whatever I need to do to not have surplus capacity. And then I can sell it at regular times at market value, so when the market's high. I mean, it sounds like your model anyway, but the gate is you need to have critical mass of these devices within their footprint to make that work, so you get the economies of scale.
Yes. So you need reliable units, which is why we're putting them out in the field, so we can get good running data, and we get to understand the installation issues. We are looking at how to scale production, so we can make them for as low as possible cost, and we're talking to the energy suppliers about how this sort of model will work. But to give you a sort of idea, the inflection point in the UK will sort of hit this inflection point where when you start installing more and more offshore wind, you get these longer periods of zero wholesale pricing. That doesn't happen till about 25, 26. We hit the inflection point, may even be 27, and we are ahead of the world. So we're trying to position ourselves so that when that point comes, we can scale rapidly and everybody's comfortable with the technology. There's absolutely, with all the best will in the world, everybody wants to see units running for several years to understand reliability points, customer feedback, customer satisfaction. Is it doing what it says on the tin?
So if we're talking scale, which we like on this show because that's part of the transition, you mentioned in the beginning that you're a small company, or fairly small, in the startup right now. So apart from the technology and production scale, which is a separate topic, definitely difficult enough, but then the other part is obviously the commercial scale. So how do I get this out to X number of thousands or even million of customers? So how do you look at this? Because that's also a window of an opportunity to making sure that the units actually goes out once produced. And with a smaller team, it's a consumer market. It's not super easy to get access to consumers.
So we're more so it's exactly fair comment. So we want units in the field to prove reliability, to understand, to understand the whole installation process. But our main focus is actually on stripping cost out of manufacturing and automating the process. So where I would like to be is within 2 years have all of the elements of I mentioned to you about it's actually a factory that can produce 10 units an hour, 20,000 units a year, because our view is that the sort of numbers you would want is 15 factories like that by 2030. So we need to design. We've got the product, but if I went to someone else in Europe, big manufacturer, I think we see ourselves. We will fit within other people's product portfolio. It's no good me taking our unit to them and they go, it weighs how much and how do I make this? What I want to do is take them a unit, go, here, it works, customers love it. This is how you make it. Now we can sign a license deal, because actually I think we're going to need to scale this sort of production in pretty much every country in Europe at the same time, because of the timing of when renewables suddenly come online. So the way to scale it is to have a proven product and factory design that you can sell to people, and they can, they've got this factory that was making gas boilers, they've got the space, and they convert it.
So the one thing I noticed, having lived in the US and moved to Europe, is we have these wonderful thing called heat waves in the summer in Europe. And so with my heat pump in the US, it didn't do really well when it got very cold. It did okay when it was cold, but it didn't do the extremes well. But it sure kept me cool when it was warm. Does this solution lend itself to any kind of cooling as well? Does that thermos analogy work for making things cool, or is it really only efficient for heat?
It doesn't. It's really only for heat. I think that would be so one of the other benefits you said, if heat pumps, if you put them into ducted systems, are great for both cooling and heating. We tend not to use ducted systems. If you try and put cold water through your radiators in the summer to cool your house, it gets quite messy. You get a lot of condensation. So I would say, while I would love to do some cooling, no. And you can drive cooling processes with heat, but it doesn't make sense. Every time I do the numbers, it just doesn't stack up.
But that means is that limited to the market, or is that just accepted? Because what I see in Europe, and Johan and I have talked about this a number of times, especially in the summertime while I'm sitting here in my apartment in the Alps, where it should theoretically be cool, and it perhaps isn't as cool as I would like. Does that really cut the market down in your estimation, or is there enough old properties and properties that have the plumbing in place and not enough new construction to go on where they would change to a different architecture, right? So those numbers you threw out, the 14 million and the 8 million of the boilers getting replaced, are people just replacing that, or are they going to forced air and things like that, like they have in North America?
The primary look, I think, everywhere is heat pumps. So depending on whether you've got a wet hydronic system or a forced air, I suspect with forced air, people will predominantly go for heat pumps for the reasons you've said, which is you can reverse it in the summer to get some cooling. It depends on where you are. In the UK, well, it's very nice to have air conditioning. Most homes don't. It's only a tiny set of the market. I suspect as you go further south into Europe, it becomes more and more popular. I think from our side, and where we are size-wise, if we got to a point where we'd saturated the market, I would be very happy.
Yeah, just curious, because that's one of my pet peeves when it gets hot here, that with global warming or whatever, that there seems to be more and more heat waves, but I don't have a long enough history in Europe to know if that's really statistical or just an anomaly. But I've lived through a lot of them, and I miss air conditioning when I live here. And I can't imagine I'm the only person on the continent thinking that way.
I'm sure you're not.
But so it does make sense what you're telling me. I like the idea of taking the energy and storing it. So what's the efficiency level of doing it this way? Do we need to go in and rewire so this thing goes outside maybe, or in the garage, or someone, because it's too heavy to carry into the house? So is there a huge electrical component that needs to get put in to create this kind of heat?
No, well, so it depends on so in the UK we design it around single phase. I think in most of Europe it's 3-phase supplies. So if we were in Europe, it'd be a 32 amp supply. In the UK, about 100 amps is the maximum supply you get in a single phase. We can draw 90 amps on a single phase, but we've put in some, I would say, smarts around the charging. We work with a company called My Energy, who make a very popular. They make a couple of products. One's called a Zappy and one's called an Eddy. The Eddy is a hot water heater that was originally designed for using excess solar PV, and we've basically built an Eddy on steroids, which means that when we plug it into the home, it can go anywhere between 0 and 90 amps. If you're generating extra PV, it can use it. If you switch your car charger on, it turns down. If you switch your your oven on, it turns down. So it's very much, we regulate and we always keep the unit charging below your fuse limit. But the aim is to get the absolute maximum through your connection to the grid that you can.
And then how does this scale up? So the other thing about being in Switzerland is we have a lot of multifamily. So not like in the US where probably many people live in their own homes. Here it's very popular. For example, I'm in a flat here. How would I scale this up for this kind? Because there's a large population living in multifamily.
With just multiple units, you can gang them together. They're like, in the sense they're like cells. You could just put 5 or 6 together to do the whole property.
And have you done that yet? Have you gone into multifamily?
We have done 2, not that we've done 2 for a specific application, which I'm not allowed to talk about yet because it's just the publicity around it's going to come out soon. But they just needed more power and more heat, so we put 2 units in. But what we saw from doing that is I could have put 5 in. It's relatively straightforward from a plumbing perspective,
And what about swimming pools? Have you done any pools yet?
No, and I would broadly refuse to do swimming pools because they are perfect application for heat pump. So you only need the water heated to sort of 28, 29 degrees. You will get very, very high COPs on a heat pump at delivering at that sort of low temperature. And it would just be wrong to use, we're really clear. We want to tackle problems that heat pumps can't tackle. We don't want to so we don't really tackle new build. We don't tackle applications like that. I just think I'd just refuse because it's the wrong solution, and I get.
And you say you're not the subject matter expert.
So, no, but I do. Well, I've done a lot with heat pumps, and I really like them. So actually swimming pools. So swimming pools are one of the best. Especially if they're used in the summer or they're outdoors, you get lots of solar energy in the summer from solar PV. It's warm. You can run your heat pump for your swimming pool, and then I go and see people, and they have an oil boiler heating the swimming pool, and I despair.
So if we go back a little bit, we talked about the technology. One thing that I'm actually very interested in is obviously the business models and how do you get it out. And we're talking here about an upfront cost if you're going to change the boiler or not, or if you're going to do it as a retrofit for something else. It is an upfront cost in one way or the other. Is there any way of looking at this? We're seeing more and more, for example, PVs, that it becomes more as a service model, like solar per hour, or is there anything you're looking for this to kind of come over the hurdle of an upfront cost and put that on to more of a recurrent cost for better ROI?
I think that has an option, but it's still quite a long way. To do a sort of heat as a service model is broadly what I was describing with the utility model, where you let them decide how to charge it. The problem is that it's quite difficult. In the UK, the regulator doesn't allow energy suppliers to lock customers into long-term contracts. So it's then hard to see. You probably want a pension fund or a third-party owner owning the asset, and you could easily see that happening. But it's very unlikely that you will get the energy supplier will want to own the heat battery, because if you switch to their competitor, then they're just sitting there owning an asset that their competitor's turning on and off. So I think from a competition perspective, you're likely to have it split into having these units should be able to be asset financed. So you can imagine a pension fund having thousands of them in a portfolio, understanding the credit risk, and they just and then at the same time the homeowner has one energy supplier and they don't like them, and they have the ability to switch to another one.
Which could be an interesting part. We're actually running some of these investment fund pensions fund on the show later on this spring. I'll make sure I'll ask that question, because I think this is a really interesting perspective. We're not just talking about heat pumps or batteries, but we're also talking about PVs on the roofs or whatever needs to be done, electric chargers for the cars. We're looking at upfront investment in this transition, and how do we get by it? And we see it a lot in the software industry, and the service industry is coming more and more to a kind of reoccurrent model. But we're also talking a lot of regulation in the energy industry, which always complicates things.
And takes a long time.
It takes a long time. Well, so does utilities. So we got double on it, I guess.
How are you going to market with this? So if you showed up my door with your pamphlet, you get your pickup truck out there, you're the heat guy, and my boiler's broken, I've called you. What's the market's reception of this? They scratch in their head. Does this seem too good to be true? Do they not believe the energy prices? What kind of questions or feedback are you getting?
So the biggest problem is that your boiler is broken and you need a quick solution. So almost certainly at this moment in time, you're just going to buy another boiler because you want your house to be warm. So with us, it's like, where's it going to be sited? So outside, do we put a concrete pad down, for example, if it's, you can go in your garage, but otherwise it's going to need a concrete pad. There are things at the moment that take time. So we're not at the position yet where I would like to be, which is where we get that call and we go, yes, we can do that. We'll give you a temporary solution for a couple of days and we'll get it all installed. But if you look at us in terms of where we are within the marketplace, you've got the early adopters. You know, our customers are before the early adopters at the moment. So, we've been to some homes where we go, not sure this is going to work, and they go, no, it really will work, and we're going, no, I think there's it's going to be difficult. No, they're going, it'll be absolutely fine, and so. But that doesn't tell us where we want to go, which is if you sort of look at the distribution curve, the sort of big block in the middle, just to sort of upfront the head, that is work in progress, which is if your average customer, their boiler breaks down, which is normally when they make a decision about changing a boiler, and they ring up and you go to them, okay, I can replace it, this is the price, but there's an alternative and we can get it in. How many of them? Is it 5%? Is it 1%? Is it 10%? So that is sort of, again, work in progress. We don't know the answer to that. But at the current moment, I love my customers. They're all interested in not producing carbon. They want to do this. They're engaged with energy. I get sidetracked regularly with conversations I get told off because we just talk about the whole house. So, but it's, that's where we are at the moment, but that's not where our long-term market is, which is, can you have widespread adoption of this just in the same way you would of a different type of boiler?
And how far away are you from that model? Because to me, that's analogous to someone that had an early electric car, or even today having an electric car. You're probably not mainstream quite yet, even though they're getting there. But
I think,
you're still a ways away from regular market then.
yeah, we're definitely regular. So I to my mind, we're at least, we're the earliest we could start doing those sort of conversations would be next year. When we might start to want to have some, you might want the conversations, but you want to have units available that are just sitting there so that somebody rings up and we go, right, can we get it into that house in 3 days? That's so we need to have both the spare capacity. We need to understand the installation process so it's really, really slick. And at the moment, you go into homes and we generally go into older homes, and plumbing is often complicated. Sometimes it doesn't work anyway, even before that, before we go in there. So to me, we've got a fair bit of work to do, but I would say the earliest I would be able to know that answer is later on next year.
And then going out to market, is this direct right now, or are you expecting plumbers and folks?
It's direct. It's direct. We're generally going to keep most of the installation in house because then it just gets done and it's in our control and everything's done to the right standards. Route to market is one of the things which is also why we're talking to the energy suppliers, because what we really want are routes to large numbers of customers, going individually via smaller plumbers, heating engineers. That's gonna, to my mind, that's not really where we want to take this. It's too slow and it requires too many people to manage.
So coming back a little bit to you mentioned when you come to the house, you look around. Obviously, you have all the discussions. We had that with EV customers. We had that with PV customers, and everyone, especially before the early adopters, or maybe now the early adopters that are very eco savvy. They have done their research and all the rest. One question. I'm still looking at this big thing behind you on the board for the people that are watching the YouTube channel. But how, if you put this into the garage, or even sometimes a block of cement or something stable on outside, is it hazardous?
No.
So you can run into it. Obviously, you get a little bit of hit, but it's not. You're going to tip it over. It's a ton, several tons. It's not hot.
It's like a in terms of it's steel, so it's a bit like a big propane cylinder, as in it's just thick steel on the outside. There's no fire hazard. You can put it next to the house. You can put it in the garage. You don't need to have it a certain distance from the house or anything like that. And surprisingly enough, when you stand next to it, because of the shape or because it's circular, it really doesn't feel as large as you might think it would be.
how did you get to that size? How is the thing that we're looking at? What makes that optimal?
I wanted to make it. Well, I wanted something that charged at the maximum rate you could charge on a single phase supply for 5 hours, which is the period of time you get cheap off-peak tariffs in the UK. So that's 100 kilowatt hours. The unit behind me stores 100 kilowatt hours. Um, it was that was sort of how I got to the logic, and I also wanted it to behave, have the same power output as a boiler, which is 30. We've put it at 30 kilowatts, but what I wanted was something that was nice and punchy in terms of power output and heat, and gave people the same sort of feeling they have at the moment, because generally I think people don't like change, and when you fit a heat pump, you need certain changes in behavior and how you heat your house, which people often struggle with.
So I know we're coming up to the 45 minutes. If we take a little bit of a sidetrack, not for another 45 minutes, because that's unfortunately not what we have time for. But I did some background research. We also had a pre-talk. I know that you're an advocate of sustainability. You do a lot of things around this. You've done a lot of battery projects kind of in your past as well. Any kind of, I wouldn't say a magic ball here, but what do you think in terms of your discussions also with home consumers? What are the main changes that are happening in the near future, and what do you see some of the obstacles now of actually moving towards what we all want, I guess, especially on this show, a net zero?
So I think current energy prices just make the whole market challenging. I think people are, electricity prices are high, gas prices are high, oil is high. I think it's making that's a negative. I think on a positive, it's making people focus. Can they use less energy? What can they switch to? I think the biggest thing I keep coming across is people where how you when you start from a relatively old, to the UK, I think we have pretty much the oldest properties in Europe. Certainly, on average, I think they're some of the least well insulated. So you're starting from a position where, and people look at how they switch to reduce the carbon, and every time they come back and they look at the bill, they go, "This is crazy. I can't afford this." People are told if fabric first, and there are types of insulation that make total sense. If you cavities in your walls, you fill them up. Your loft, you do it. When you go and do some of these other things like solid wall insulation on the outside of a building, it never ever ever pays back. Just and so people keep getting these bills and they're going, I'll just buy another gas boiler, because I think the bit I think is lack of clarity. There's lack of guidance from the government. There's lack of trained people in the industry, and I think homeowners are generally confused because they want to do the right thing. They get so many different opinions. Someone says this, someone says this. There's very little clear guidance, and they end up just going, I don't know, so I'm going to stick with what I've got. And I think the lack of clarity from the government makes it very hard for the industry. It's 1 minute there's lots of, this is going back to the grant idea. Remember solar panels? 1 minute everyone was installing, the next minute the grants have gone, and suddenly all your work has dried up. So and consumers don't want to switch because they're used to having the grants. So I just think I'm not a fan of grants. I think the government can give support. It can give zero rates of VAT. It can give sort of more soft and fairer levels of support around electricity pricing, all of which would, to my mind, drive it in a more consistent manner. So at the moment, I think the UK is not moving fast enough. I think the government wants to move faster, but heating your homes has always been difficult from a decarbonisation point of view.
I think what I hear from being in this podcast and being in the energy business is it's complicated. There's a lot of choices. There's a lot of fit. Even in this conversation, what I appreciated you doing is qualifying out where it fits and where it doesn't. And you're like, absolutely, I don't want to do a swimming pool. Cool, I get that. Does it fit in every house? Probably not. But there's certainly a market and a piece for every element. My final question that I'm curious about is, where are you as a company? So I think you mentioned that you're not really hitting the market till next year. You talked about scaling up, so that usually involves some sort of third-party funding from my experience of starting companies. Where are you guys? What are you doing?
So we had a really good fundraise last year, and we were very lucky. We got a very nice grant from UK government. So thank you very much for UK government. We are likely to go out fundraising sometime around Q2, Q3 of this year. Hasn't been set, and that will allow us to scale up and start selling what we've got. I think we've had over 50 people pay deposits, which is around 6 months of production for us, of where we're aiming to be this year. So to scale up and do that, yes, we will need more money. I think we haven't set an actual time frame, but if we do go out, it'll probably be very similar. Most of our investors are high net worth investors and private individuals. We haven't gone out for institutional funding, and we're probably around away from that.
And it seems like, based on what you just said, have you considered crowdsourcing? I have a friend that did an e-bike company over in London that has done very well with crowdsourcing and building one of the largest e-bike companies in Europe or in UK.
So we went on Crowdcube last year. I don't know that went really well. So we smashed our targets. We had masses of inquiries, and one of the advantages of crowdfunding for a consumer-facing product like ours is you not only get investors, but you also get customers.
Get the pipeline. Exactly.
Yeah.
Well, this is exciting. I appreciate you coming on our program and sharing with our audience. I want to thank you very much for being our guest. It's been fascinating to me. Johan, any final thoughts?
No, likewise. I'm always fascinated when we bring on topics that are barely new or fairly new to us, or sometimes really new to us, and as consumers and households. Even if we all have our households at home, we, as you said, we don't pay enough attention maybe to this. So for me, it's fascinating, really interesting. Even though I live, my house up in the Scandinavian countries is very isolated because we need extremely isolated houses, but we also need a lot of heat. So look forward to seeing you there.
Brilliant. Well, look, Chris, Johan, thank you so much for having us on and giving me a bit of a chance to talk about Caldera and what we do. I'm amazed an hour has gone so quickly, but thank you very much indeed. And, maybe we'll be able to give you an update in a year's time or something like that.
James,
Perfect.
I'd very much like that. I like to see where are they now. MTV does this. Where are they now, or behind where they've gone? So I do anticipate coming back to our earlier guests just to see, especially companies like yours, where it's been a passionate story and there's a lot of opportunities. So thank you again. For our audience, you spent another hour listening to Insider's Guide to Energy. If you've enjoyed the content, please share it with your friends and don't forget to hit that subscribe button. Follow us on LinkedIn and watch the YouTube channel, and you can see what this device looks like in the background behind our guest. Look forward to speaking to you again next week. Bye-bye.